Hello guys, this is Tafadzwalnyamukapa from StackDev and welcome to my YouTube course. So today we're going to look at an interesting problem which is called the two-sum problem. So this is kind of a medium. It's a bit of a challenging problem if you are not familiar with some of the tricks and concepts. So I'm just going to take you through this. So let's just quickly go ahead and dive in. So the problem says given a one indexed array of integers which are numbers that are already sorted in a non-decreasing order. Okay, so these are some of the things that you need to quickly start to take note. Here the problem is telling us that this array is sorted. Okay, so this is a keyword for the most part, which usually means that there might be some techniques that you can actually use if an array is sorted. And it also goes ahead and say in a non-decreasing order, which means this array is sorted like in increasing order, so which means the numbers are increasing. So it's saying find two numbers such that they add up to a specific target. Okay, so in our array we need to find two numbers so that they add up to a specific target. Let these numbers be the numbers of the indexes 1 and index 2, and they should be in this range. So this is also important. We can actually see that our array should be in the range of 1 to the maximum length of that array. And we know that from an array perspective, arrays is indexed from 0 actually to maximum, but the solution here, they want us to index them from 1 instead of 0. Okay, so this is another key point. Return the indices of the two numbers, index 1 and index 2, added by 1. Okay, so this confirms what we just said here. So which means for those indexes, so if an element is on index 0 and 1, we need to return 1 and 2. Okay, is the positions. So it's saying those indexes are added by 1 as in the integer, index 1 and 2 of length 2. So it's supposed to return 2 elements inside that index. The tests are generated such that they return exactly one solution. You may not use the same problem twice. Okay, so this is okay. So this problem is on LeetCode, and they've given us a couple of examples here. So the first example is saying given an array of 2, 7, 11, 15, and the target is 9. We want to find two numbers in this list that gives us this target 9. Okay, so in this case, just by looking, you can actually see that our solution is 7 and 2. These are the two numbers that gives us 9 if you add them, and they are on index 0 and 1, but in this case they want us to add index by one number here, so which means the solution will be 1, 2 instead of 0 and 1. Okay, so this is the solution. And yeah, there are a couple of examples. So I'm simply going to switch to some sort of a board where we can actually go ahead and take a look at this. So the approach that I'm going to take here is I'm going to try to demonstrate this solution in two ways. Okay, the first way is the brute force attack. Okay, where we can actually go ahead and brute force it and do a naive solution of this. And then the second way, which is most important, there is a technique called the two-pointer technique, which I'm going to introduce to this video. Okay, so let's just start with the brute force. So let's say you have an array, okay, of let's say 1, 2, 4, okay, 7, and you are given a target. In this case, let's say our target is 6. Okay, we need to find two numbers that adds to this. So with the naive approach, right, we need to just, you know, hold a position here. Let's say we have a pointer or something like an index I, which is going to hold, and then this is going to be like an outer for loop, which is going to iterate through this list. Okay, and then we're going to have another one, and inside one, let's say maybe J, and inside pointer, which is going to do now the combinations. So for example, the first combination of I is going to start at 1 here, okay, this input element 1, and then the J is going to start at 2. So it's going to say 1 plus 2 is it equal to 6? No. Then it moves on to the next. So j will move on to the next, so it will come here on 4. Then it does 1 plus 4. In this case is 5, it's not 6, so that's not our solution. Then j will increment again, and it does 1 plus 7, which is 8, which is not 6. So for this first loop, you can actually see we haven't found our solution. So what then happens is I would then need to increment to the next element. So in this case, I will be here on 2, and j will be on the next element. Okay, so it will start 2 plus 4 in this case on the second iteration. It's actually 6. So we'll then find our solution, and then we'll return, in this case it will be index 0 1 2. So in this case it's 1 2, so our solution will be 2 comma 3. Okay, so this is a brute force solution. So you need 2 for loops, and a brute force solution, if you have a double for loops like this, it's usually like O of n times O of n, because you are iterating twice. We have a nested for loop, so the solution will be O of n squared, which is a bad solution. But it's important, you know, for you to know how to implement this. So let's just quickly implement the brute force, and then we'll try now the optimal solution. We'll try to optimize this. So for our brute force, let's expand this a little bit. So in this case, for our brute force, the question, let's see, is there anything that we've missed? Okay, so yeah, these numbers are positive numbers as well. It's also important we don't have negative numbers. But the target can be negative. Okay, all right, yeah. So let's try to tackle this. So what we'll do is, we need, for our brute force attack, we need an index, let's say I equals to 0. This is going to be our outer loop, and I less than numbers dot length. This is going to be the length of our list, then I plus plus. Okay, so this is going to be our outer loop. Then the one that is going to do to compute the combination will be the j pointer. So j less than numbers dot length and j plus plus. Okay, so this is numbers actually. Okay, so what you want to do is, remember, it's going to do, you know, combinations of this. So I'm simply going to declare maybe a variable called sum, and I will say sum of numbers of I, then I add it to the element of numbers that j is currently pointing. So actually, remember, our j, we don't want it to start at 0. Okay, we want it to start at the next element. So here maybe I'll initialize j to say I plus 1. So I is at 0, j will start on the next element. Okay, so that, you know, we won't have to, we're trying to optimize this bad solution. But let's see. So here we then do now our condition check. So in this case, we're going to say now check like if the sum equals to our target. Okay, so if the sum is equal to our target, we now need to return, we actually need to return our solution, which is our indexes. So for our index, maybe at the top here, I can maybe declare an array, which I can call maybe result. Then I'm going to initialize it to 2. Okay, so the reason why I'm initializing to 2 is, remember, our solution is always going to have 2 elements in our array. So this actually, initializing this actually, it's constant. So, you know, our runtime solution of this is constant because we have declared 2 here. It's not going to be determined by some length. So it's constant here. So our memory space here is going to be constant. So maybe I might not need to return here. I can actually say now result, so result dot 0. So for my 0th element, if I found the target, I'm going to initialize to where my index I is. But remember, they said the index I, we are supposed to add 1. So I'll also do the same for the next index. which is j, where my j currently is when we find the elements that are giving us this sum. And otherwise, if they don't match, I'm simply going to continue with my iteration. So it will go to the next element and look for the next combination. So at the end here, I'm simply going to say maybe return result. So here I'm now returning my result here as per our data type. So our data type is an integer array. So this is what I'm going to return. So yeah, this looks like our brute force solution. Let's try to run it. Let's try to run it. Okay, so it looks like there is an issue. So new int. Okay. So there is an issue again. So number is actually numbers here. Okay, my bad. Let's try again. So this is numbers of I and J. Oh, here I was using I. Okay, so it's supposed to be J. I made so many typos here. Okay, let's try again. Fingers crossed. Okay, so yeah, this looks like it worked. So you can actually see that it did our test cases 0, 1, and 2, and it passed, it passed, it passed. So let's try to submit this. So like what I said, since we have two nested for loops, the runtime of this it's going to be O of n squared, because this is a, this is not an optimal, it's a quadratic runtime here, and the space of course is constant. So let's try to submit this and see if they're going to accept our brute force solution. All right, so this is not an acceptable answer for the most part. Time limit exceeded. And let's try to analyze the complexity of this. Okay. Oh, all right. Oh, okay, it worked. Okay, so if I can analyze complexity of this on LeetCode, they have this new interesting feature. You can actually see that our complexity is O of n squared, which is not a good solution. So what I will do next now is let's now explain now a technique called two-sum. Sorry, a technique called two pointers. So for our two pointers technique, so like what I said, it's a technique that you can use, to optimize these things, because the idea of these algorithms is, especially these array or strings related algorithms, you only want to make your computations by running across this array once, okay? Which means if you do your computations or any logic that you're doing inside the for loop, you just only want to do it once. You don't want to come back again and try other combinations, so that our solution or our answer will be O of n, okay? We just want to do it once. So how best do we do that? So for us to do that, we can use a technique called two pointers, where the way it works, let me just rub this a bit. So the way it works is, in this case, we have 1, 2, 3, 4. I don't know. Then our k is, let's say, I don't know, can put it to maybe like 5. Selecting this two. So let's say if our k is 5, the idea is you want to have some sort of like a left pointer here, which is going to point at the end, and our right pointer at the beginning, and our right pointer which is going to point at the far end of your array. And the idea is you want to do a single iteration. Remember, like what you said, you want to do a single iteration such that you are comparing some two numbers, okay, or these numbers against your target. If the numbers, so since this is sorted, what it means is we have guarantee that, for example, if we compare, if we say 1 plus 4, the answer is 5. we then say is 5 less than or equal to 5. In this case, is 5. Oh, actually, okay. So in this case, it would then work here. 1 plus 4, 5. Yeah, it would then return the solution. So maybe let's try something like 4, 5, 6, 7. Let's try 7 so that I can explain it better. So it will say is 1 plus 4 is 5. Okay. Then it says is 5 less or equal or above our target here, which is 7. So in this case, 5 is a lesser number. So what it means is we need more numbers. So the idea is you either want to decrement this to point to the next element, or you want to increase this. So here, since our array is sorted and we have found that the current solution for these 2 pointers right now, it's actually 5, okay, and 5 is less than 7, okay, there is a higher chance that maybe if we try another number here, if we move our L to point to this, there is a high chance that we are going to get to 5, because we're going to get to 7, our target, because it's an increasing, it's sorted, so higher numbers are on the right side. So there's a high chance that if we move our pointer to point here, we're going to find a number that is going to satisfy our condition, okay? But if it was a lesser number, so for example here, we then do 2 plus 4, in this case, L 2 plus 4 is 6, and 6 is less than 7, again, we need to increment this L to point here, okay? And this is being done once, okay? Then we try again, 3 and 4, 4 plus 3, in this case is 7, that's our solution, we found it. But let's say if this number, let's say it was going to be less, let's say maybe we're looking for 3 as our target, for example, and then we started 4 and 5. In this case, we got 5 when our L was still here and our R was still here. We got 5, okay? 5 is bigger than 3, okay? So which means our solution is on the lesser side of the numbers. So in this case, we need to decrement this R here. So we need to decrement and point R to 3 in this case. So R will be here on 3, on this 3 here. Then we try again. This L is holding 1 plus 3, it's 4. 4 is still bigger, so we decrement again R, then we go to 2. So our R is now here. Then we try again, 1 plus 2, in this case 3, we have found our solution. So with this approach, it only works, especially in this case, like our array is sorted and your numbers are increasing. So you are guaranteed that your solution is either on the side. So the condition to move the L's or the R, your right pointer, your left pointer, is depending on the solution that we found when you do the check. So let's just quickly go ahead and try to translate this to code. I hope this was clear. So let's try to attempt to do this with code now. So what I'm going to do now is I'm going to delete our brute force solution. Maybe we might need the result. I'll keep it. So I'll delete this. Okay. So in this case now, we now need 2 pointers. Okay. So we need a left pointer, which is going to point at the first item of our index to the left side, and we need a right pointer, which is going to point to the last index. So it's basically numbers dot length, so the length of the array minus 1. So this is going to point at the last index. Okay, so once we have this, we can put this in a while loop. Okay, so we want to do some combination like a computation like while left pointer, this is now our holding condition, is less than right. Okay, so as long as our left pointer is less than right, we want to continue those movements, either we're moving to the right or to the left of our pointers, and then we'll only stop when these guys clash or when this guy meets. Okay, that's the algorithm here. We'll do more examples of this in the following tutorials, but for this, just hold it like so. As long as our left is less than the right, we want to do the combinations. So the first combination, the first thing that we want to do is, first of all, we want to check the sum, like what we did with the brute force. So the sum at this current position here is going to be numbers of left plus numbers of right. Okay, this is our current sum, and then we do our comparison. Okay, this is some logic now, because this logic is the one that's going to tell us whether we're going to move the left pointer or the right pointer. Okay, so we're going to say if the sum is greater than the target. Okay, so actually we can even start with equal to. Let's start with if we find it. So if the sum equals the target, okay, it means we have found our solution. So we want to initialize the result here to where our left is, okay, plus 1. Remember, that's what was required. And then we do the next element, we initialize it to where our right pointer is, plus 1. Okay, right. Then this is the first condition. So we can do maybe an else if. Okay, so else if sum is greater than the target. So if sum is greater than the target, what it means is we have a higher chance of finding our solution to the left side. So we need to shift the right pointer. We need to decrease it because this is greater than the target. So we need to decrease the right pointer here. So we can say right minus minus or right equals to 1. So this is the condition that is moving it. Okay. Else it means sum is less than this. Okay. We need to increment the left pointer, which is on the left. So we need to add it to move to the right. This one we are decrementing it. And that's it. So these are the two moving variables that are determined by this condition, whether the sum is above or lower. This is how these 2 pointers are going to be moved. Otherwise, we'll then look forward to meet our solution here. So once we do this, we then exit our loop and we return the result. Okay, so let's try to run this. Okay, I've already returned the result before. Okay, cool. So I'll try to run this. Okay, so this is complaining time limit exceeded. It looks like our solution is not optimal. All right, let's check our exiting points here. So we said if you find our solution, we do this left, right. Okay, this is okay. Then we initialize our left to 0, our right to maximum length minus 1, which is okay. Then here, let's check again. So if the sum is greater than the target, okay, so if the sum is greater than the target, it means our right pointer needs to go to the lower side. Okay, then else if the sum is less than the target, then we need to move to higher numbers. Okay, so actually whenever I find the result, I need to immediately return the result here. Otherwise it's going to do the permutations of the rest of the thing. So I need to immediately return it. Otherwise I'll just return what I have here. So let's try to run it again. Yeah, it looks like it worked. Let's try to submit. All right. So our solution is submitted and it beats 93% of the submissions. So yeah, that was it for this tutorial. I hope you found it helpful. Just look forward to the next tutorials on this. I'll be uploading some couple of videos. I'll make this a series. This is going to be a series. So thank you guys for watching. Don't forget to like and subscribe. I will see you in the next one.